You're welcome to your online class. I'm your teacher, Mr. Okiti Okemukumu Ahmed. So we'll be looking at electrolysis today. We have been doing some things, so many things on electrolysis, and we'll look at the potential discharge. We'll look at the difference between electrolytic cell and electrochemical cell. So what we are going to look into today is one. We'll be looking at what we mean by electrolysis. We'll also be looking at what we mean by electrolytes. We'll also be looking at what we mean by what? Electrodes. Then we'll also be looking at the electrolytic cell itself. Electrolytic what? Cell. Okay. Now, what is electrolysis? Electrolysis has to do with the chemical change that takes place in an electrolyte when current is what? Passed through it. Okay. Chemical change that is brought about when current is passed through water electrolyte, so we call what? Electrolysis. In other words, it can be defined as a what? The chemical decomposition of what? Of an electrolyte, either in its molten state or aqueous state, into its component what? Ions, or let's just say the composition of this electrolyte into what? Various ions, or okay, the chemical decomposition of an electrolyte by passage of what? Direct what? Current into it through its what? Electrodes. So we call what? Electrolysis. Okay, so electrolytes are the substances that allow current to pass through them. Then we have what? Electrodes. Electrodes are the conductors, the wires. Okay, as we have said, we have the negative electrodes. We have negative electrodes. The negative electrode is called the what? The cathode. The cathode is a negative what? Electrodes. Then the anode is the positive what? Positive what? Electrodes. Okay, so it is the cathode that is connected to where? The negative terminal of the battery, the power source. Okay, power source. Then why the anode is connected to the what? To the positive terminal of the power what? Source. Okay, so the various things you find there are what? The power source. You have the electrolyte. We have the electrodes. They are all together in the what? Electrolytic cell. So electrolytic cell is a compartment. Okay, it's a compartment that consists of what? That contains a power source or electrodes connected into what? Electrolyte place. Now let's look at the mechanism of electrolysis. Mechanism electrolysis. Now, when you have an electrolyte, an electrochemical cell with rods connected, that's the electrodes connected now, and maybe it's connected to a power source whose tap or gap is what? Closed. So this is the power source. This power source can be a battery. Okay, can be what? A battery. This is the negative terminal of the power source, so you can call it the cathode, anode. I mean, that is the positive terminal of the battery. You can call it what? The cathode. Okay. Now the negative terminal of the battery is normally connected to where? The anode. Okay. Then the positive terminal of the battery is normally connected to where? Sorry, this one is normally connected to where? The cathode. While this one is normally connected to where? The anode. So in electrolysis, in an electrolytic cell, the anode is positively charged, while the cathode is what? Negatively what? Charged. Okay. Now, when there is a gap, in other words, current has not flowed, the ions are free to what? To move about. Ions are free to what? Move about. They move about very freely to any of their direction. But immediately current is passed through it, what happens? Immediately current is passed through, or let's say the gap is closed. When the gap is closed, current will flow. This is what happened. We are discussing about the mechanism. The negative terminal of the battery will pump electrons to the cathode. So electrons will enter here. So here will become full of electrons. As this thing is taking place, as it's taking place directly, electron is taking place. So what happened? Here, this place, current is entering this electrolyte. Now, at this point, when these electrons are deposited here, current leaves electrons leave the electrolyte through this positive terminal called what? Anode. Electrons leave there. Through the anode, the electron will leave to the battery. In other words, the battery will what? Will draw electrons from the cell. Then here, through this side, the electron will be popped into this place. Now, at this cathode, when the electrons are here, what happens? The positive ions, called the cations, will now what? Will migrate to where there is electron to what? Receive electrons. So as they receive electron, what happens? They get what? Deposited. In other words, assuming it's a metal that's positively charged, because it receives electron from the cathode, what happens now? It becomes what? Reduced. It becomes what? Reduced. Okay? So that's why you see that what? At cathode, reduction what? Takes place. Reduction takes place. So what takes place in at the cathode is what? Reduction. Okay? Good. Now, at the anode here, what happens? What happens at the anode here? So the anions, the negative ions, move to this point. Now, when they get to this point, they deposit what? Electrons here. And at the end, they become what? Reduced. Now, assuming the ions were, let's say, Q ion. When it goes to the cathode, to the anode, it dumps what? Electron there. It becomes what? Q. So it can be a gas or whatsoever. Let's say gas plus what? E minus. Okay? So at this point, it becomes what? Oxidized. Okay? It becomes what? Oxidized. So it means that at the anode, what is taking place is what? Oxidation. Oxidation, okay? Oxidation takes place at the anode, while reduction what? Takes place at where? The cathode. Okay? So that's the mechanism. What happens during electrolysis? When current passes through it, what happens? The various ion, cation moves to where? Cathode. Receive electron and they become what? Reduced. Then the anode, what? The negative ion go to where? They migrate to the anode. They dump electron and become what? Oxidized. So that's, and the process keep on going. In fact, current is flowing through. That's the process that takes place. Okay. Now the next thing we are going to look into now is let's look at some examples of electrolysis. Some examples. What we are going to look into now, we are going to look into one, electrolysis of what? Acidified water. Electrolysis of acidified water. Two, we are going to look at electrolysis of copper tetraoxo sulfate 6 salt. Then we're also going to look at the electrolysis of brine. Electrolysis of what? Brine. These are the three things we want to quickly look into. Now, take note, it's not the acid that has got electrolysis, it is water. The effect of this influence will form makes it to what? Makes the water to what? Acidified. Okay? So the electrolysis of acidified water is electrolysis of water. Okay? That helps the what? To keep what electrolysis of water. That's why the quality of electrolysis that helps to detect the what? The complement of water. What makes it what? following. Okay, here's the negative terminal. Here's the gases can be collected because electrolysis involves the production of what? Gas. Okay, so this is what happened here. So water, the acidified water is normally poured into this compartment, and the water fills it. Okay, the water fills it. Now the gas will be collected at where? This point. Now what happens is that when current passes through it, the various ionic components that will be present are, you have hydrogen plus and OH minus for water. Then you have H plus and SO4 2 minus for the acid. Okay. Now here there's no competitive ion, so hydrogen will be at this point. Hydrogen at the cathode will be discharged. What happened? See that the hydrogen will receive 4 electrons at the cathode. When it receives electrons, they will become what? Reduced into what? Hydrogen gas. So you see that hydrogen will be collected here. Hydrogen gas will be what? Collected here. Okay? But at the anode, there are two competing ions. We have hydrogen ion and SO4 2 minus. Now, because OH minus is higher in the electrochemical series, to be discharged in preference to this. Okay? OH will be discharged in preference to this. So what happens is that we have what? The OH will go to the anode, deposit electrons, and become what? Oxidized. So in this case now you have what? 4OH minus to become what? 2H2O liquid plus O2 gas plus what? 4E minus. So these are what takes place at what? So at this point, oxygen gas is liberated. Now you can see that the ratio at which the gas are collected are what? 2 to what? Ratio 1. So the ratio is what? For that is hydrogen oxygen collection. Hydrogen is 2, oxygen is 1. So it's always what? 2 to what? Ratio 1. Okay? So that's acidified what? Water. The electrode that I use are what? Platinum what? Platinum 4. You don't use carbon because carbon carbon, okay, or graphite. So that's the electricity of acidified water. The next one we want to quickly look into now is the electricity of what? CuSO4 solution, copper sulfate solution. Now, at this point, you have, it depends on the electrode that you use. Okay, so when you have a solution of copper sulfate, Then for the water component, you're going to have what? H plus and what? OH what? Minus. These are the various ions we are going to find inside. So you can see that there are competing ions for the cations. So meaning they both go to where? The electrodes, the cathode. When they get to the cathode, copper is lower than hydrogen electrochemical series. So since copper is lower than hydrogen electrochemical series, for metals, it is the one that is lower in the series that will be what? Discharged in preference to the other. So copper will be discharged in preference to what? To hydrogen. Now at this point, you are now going to have plus what? 4E what? Minus. So water is what? Oxygen is produced. So you can look at the electrolysis of a copper sulfate using any other electrodes. You know, copper will be deposited here as copper atom, pure copper atom. Then you see that the solution will become deficient of what? Copper. Then at the anode, oxygen will be what? Produced. But what of the case where you decide to now change the anode? Maybe the anode now, the anode is a copper, is a copper rod. If the anode is a copper rod, then what will you expect? Look at what will happen. Now, in this case now, what is going to take place is pure what? Electroplating. Look at it. Copper will go to this place, pick electrons, pick electron become reduced. So the mass of these electrons will be increasing. The mass will increase due to electron deposition. Okay, copper will be deposited. Then what will happen? Look at it. As this copper, as the copper ion present here are getting reduced and are deposited here, the anode here will be dissolving. That's copper anode will be dissolving and entering the what? The solution. Hope you know the anode is made up of copper. So as the ions are removed from the solution, this one is dissolving to form the ion back. So meaning this one will go back and form what? Copper 2 plus. Okay, so as this copper 2 plus is used here, deposited here, this one is dissolving to form what? Copper 2 plus. You see that the size of this electrode will be what? Reducing. The size of the electrode will be what? Reducing. Okay, this is what we call pure what? Electro what? So you see that at the end, it's the position that will be taking place, okay? The position that will be what? Taking place. So that's what happened here. So the next thing we are going to look into now is electrolysis of brine. This will permit us to show you that we should have it in mind that the electrolysis of brine is the kernel of this. Method of the and different method. Okay? what? Cell. And in this case, the cathode is mercury. Then the anode go to use what? Graphite. Okay. Now, what happened here is that during the electrolysis, now the electrolyte is brine. Electrolyte is brine. Brine is what? The normal table salt, sodium chloride. The solution of sodium chloride is what? Brine. Now, at this point, what happened here is that during electrolysis, mercury is a liquid and it floats. It keeps on floating. Now, are you getting what I'm saying? Mercury have what? Affinity for what? Sodium. Now, at this point, when current is passed through, mercury will react with sodium to form what? Sodium what? Amalgam. Sodium what? Amalgam. Okay, and this is the form in which the sodium will be taken away. Instead of hydrogen to have been produced now, because of the nature of the electrode, this electrode has affinity for sodium. The sodium will, mercury will attack the sodium and form association, an amalgam. You form an amalgam with this, and the mercury will take it away. Okay, we take it away from here, the compartment. Now, when you take it away to the compartment where there is water, immediately, mercury does not mix with water. Immediately it gets to where where water is. You see that the sodium will now react with what? Water. Sodium will react with what? Water. To give you what? To give you sodium hydroxide. Then hydrogen will what? Liberated. Okay? Hydrogen will what? Liberated. Plus what? Plus mercury. Okay? So this is what takes place. This is what takes place. That's why sodium points also be favored because of increase in what? Concentration. Okay, so this Cl minus, the Cl minus will drop an electron or deposit an electron and become what? Oxidized to what? Cl2. Okay, and this will be reduced. So these are some of the ways. That's why we have what? Chlorine gas, hydrogen gas, and sodium hydroxide as a product that are what? Produced. So that's what